Alright, so we're back with the control unit for the Seeburg jukebox I'm working on. This is just a quick update to show that we've finished the replacements. We've got all of our new electrolytics installed, and I went for all name brand stuff. You got Nishikon's, Illinois capacitor, and Verth, that sort of thing. New non-polarized over here, new one down there. I also went and checked the carbon comp resistor values, and there was only one that was out of tolerance by a few thousand ohms. All the rest of them spec'd in right at what they were labeled for, especially the larger power resistors. So all that works great. Went ahead and got a new 32 volt 15 amp fuse for that supply right there. Fired it up, checked the voltages, made sure nothing burned alive. And yeah, it's ready to go back in and to see, hopefully, with the new fuse and everything installed, the head unit should start to scan when you flip the service lever, or at least I'm hoping it will. Try to take some video of that if anything happens. One other interesting little thing about this, I discovered while testing the voltages, there's a panel on the side here that you can check for. Well, there's a number of connections here. The right read stuff is for the toroidal matrix system you use for selecting the record, and unfortunately I have no idea what those values ought to be, but I was able to check the two listed voltages, the 150 and the 27 volt supply that this has, and I wondered, well, in a device that only has one transistor, where are they getting two stable voltage references from? And it turns out they are getting those, bring this in a little bit, they're getting them from these two diodes right here. This one's actually tucked away behind the this relay, but this one over here is a 150 volt Zener, and this one over here is a 27 volt Zener. And that's it. It's just a simple Zener reference. There's no series pass regulator or anything. It's just these two diodes providing the reference voltage. So it's a rather brute force way of doing it, considering that the amplifier, the audio amp, probably has power transistors. I'm surprised they didn't go with a simple series pass or something, but yeah, I suppose that works if it's not going to be under too big of a load. I mean, the fuse on this is only, what is that? Well, that one's 1.5 amps. This one down here is an eighth of an amp. So obviously they weren't intending it to provide to take a lot of power or whatever it's supplying. But that's all we've got for now. Gotta wait to reinstall it. Hopefully that'll be the next update here. Okay, I'll be honest, I've probably taken this video 3 times by now, but I keep screwing up the information I talk about in it. So yeah, let's try from scratch. So since I've already got the solid state control unit for the Seeburg SS-160 finished up and reinstalled, and since I don't have the ability to go back and work on it right now since the owner's away, I am continuing on with the auto speed unit. Now, for a while I was kind of confused onto exactly how it worked and what it did. I kind of figured that it would be for controlling the speed of the motor that drives the records. That way you don't get distortion, they don't play too fast, too slow. But it's actually a little more interesting than I initially thought. For one thing, I saw this enormous power transformer on here, and then I looked at the cord and said, okay, well, unlike every other module in the unit, it doesn't have a standard 120 volt cord attached to it. It's just got this plastic header. So what's the deal with that? And you've got these two power transistors here, and some smaller coils, and if we look at the end, we've got a speed selector potentiometer and a test point. Well, after looking over the schematic and reading the rather wonderful and long 300-page manual on this particular model, I have finally figured out how it actually works to an extent. So, for the longest time, I thought that the jukebox was designed to play 45 RPM records. I mean, that was what the owner wanted to load in it. That's what it was really built to kind of advertise for album covers and all that. But then I went into the manual and it started looking at the schematics, and it described the operation, and as it turns out, the jukebox by default is designed to play 33 and a third RPM records. So in normal operation, and when you select a 33 and a third, it'll pull it onto the carriage, it'll press it onto the playhead and start playing it, and everything goes normally. So the motor that runs it is a 120 volt AC motor, but it's designed with field windings so that it can be reversed, and so that its supply can be changed to operate at different speeds. So by default it runs at 33 1/3, but since 45s are really popular, you also need to be able to run at that speed, and I just assumed that they had some method of, maybe they used a step-down transformer and just ran it at a lower voltage or something. But actually what they did is you have, the 120 volt connection for the motor is diverted through this plug from the solid state control center, passes through into here, and more importantly, it passes through this relay at the bottom right. Now in normal operation, this relay is in the open position. It just sits there, and the 120 volts from the cord passes through, hits the relay, and just goes straight back out and into the carriage and operates the motor at 33 1/3. Everything's fine. However, if when you select the 45, it pulls it up onto the carriage, there's, I forget exactly what, there's like a sensing switch or something along those lines that detects that you're playing a 45, and it triggers the coil in this relay and pulls it in, switching the normal 120 volt main out of the motor circuit and hooking up everything in here to that circuit instead. So what it'll do is there's also a 24 volt DC rectifier set up here. We've got a full wave rectifier with these diodes and a filter capacitor for the ripple. And the 120 volts comes in, passes through a step-down transformer. I'm sorry. It doesn't pass through this. The 24 volt AC actually comes off of the solid state unit. It comes in, gets rectified into DC, and then you have these two power transistors here with these capacitors installed, and there's also a series of chokes and another transformer that's set up as an astable multivibrator. It's just an oscillator producing a square wave output, and you have an inverter. You have a DC to AC supply. This circuit takes a 24 volt DC rectified input and produces a 120 volt AC 80 cycle output. The motor at 33 1/4 normally operates at 60 hertz in order to get that speed, because the speed at which an electric motor operates is based on the number of poles it has and the number of phases it has, and more importantly the frequency at which it's run. Voltage does play a part in that, predominantly is frequency, poles, and all that jazz. So what they decided to do is, in order to get it to play at a faster speed, they simply increased the frequency that the motor ran at. So when this pulls in, the oscillator kicks in and drives a power transformer to develop 120 volts at 80 cycles on the other side of this guy, and that is routed through the relay to the windings in the motor and runs it at 45 RPM. But what's interesting is, instead of your usual RC style of oscillator where you're using a resistor and a capacitor as the timing element, this one actually uses inductance, which is kind of neat. And the way it regulates itself, it actually has, based on the schematic, it's sort of like a tickler coil. So one of the, I think it's on the output transformer itself, there's an additional winding, a small one, that's all the way out that acts as a feedback into the circuit to help with the overshoots and maintain stability. It's pretty neat, actually. And then this potentiometer up here is rated at like 1.3 ohms or something. It's really tiny, and that's helped to, I think it changes the impedance of the circuit and also alters the output frequency. And then the test point here is so that you can check and see whether or not it's running right. Now, for actually doing that, you'd need an oscilloscope or a frequency counter. The average guy buying a jukebox isn't going to have that, so what Seeburg did was they offered some basically 33 1/3 and 45 RPM discs that would clamp into the carriage like they wouldn't be in normal play, but they would have a pattern on them that when you'd shine a light on it and it would spin, you could see like a certain blur, or you should see a certain image when it's rotating at exactly the right speed. It's sort of like the on really fancy record players, so they'll have a frequency adjust, and the outside edge will have a series of dots on it, and when the dots are perfectly stable, when the light is shining on them, you know the frequency is locked in and you've got it set up just right. Same basic principle of that. You adjust this until the disc spinning in the carriage looks right to the human eye and you know it's good. Or, you know, just stick a record in there and see where it sounds silly and where it doesn't sound silly. That's what I would stuck be doing. Or, since we have modern technology nowadays, hook an oscilloscope up to this that can also measure frequency and just set it up to 80 cycles and you're good to go. Now, I'd already done videos on this before. I had the parts to recap it. The only thing I have not replaced is this guy. This is a motor start cap that they inserted in circuit. This only goes into circuit when the relay pulls in and runs in 45 RPM mode. Now, these things are really expensive, and at the moment I'm trying to avoid spending a lot of money on it. So for right now I'm going to leave that in. I'll make sure that it's not a dead short or anything across there, and I'll talk to the owner and see what we can do to get the funds to replace this, because I'd really like to, just for safety's sake. But right now we're just trying to get basic operation up and running, so if I can at least get the thing running with 33 1/3, that'd be great. But after I installed the solid state control unit, what I discovered is that the motor in the thing is actually stuck. It's either the motor or it's the gear train. I'm willing to bet it's probably the gear train, because the motor was at least trying to spin. The 15 amp fuse for the 24 volt circuit in the solid state control center actually blew after a little while, just like it had previously when I replaced it. So my primary goal right now is, once I get this back in, is I'm going to have to disassemble the carriage and re-lubricate and readjust everything according to Seeburg specs. Oh joy. If you've ever seen the manual for a Seeburg jukebox, specifically for the actual carriage and the playhead assembly, it is a mechanical nightmare of clutches and assemblies, and if you don't have everything in just the right spec, especially the clutch, if the clutch is out, it'll reject records, or it won't play them correctly, or it'll skip trying to play them. It's a mess. It's an incredibly complicated and very well built mess, but a mess nonetheless. So that's where we are. Auto speed unit is ready to go back in for the while being, but more importantly, I need to do all the necessary mechanical adjustments and lubrication to make sure that the carriage and the motor are freely spinning and running, because really that's what's stopping me from getting the scanner to work. Because how it should work is, you fire it up, you put in a coin or fake a credit with the service switch, and then you enter the letter and number combination, and once you've done that, the unit should start scanning, and it'll do that twice. It'll scan left to right 2 times, and if it doesn't find what you want, you have to re-enter it. I think. I would assume it doesn't just take your money at that point. That'd be kind of cheap. But yeah, you get 2 scans and then it resets. Now, all of these scan controls, the switches and the relays that control the forward and reversing of the motor, all operate off the 24 volt AC line that has the 15 amp fuse on it. My guess is, since the carriage is stuck midway through travel and the motor is not running, everything is just pulling more current than normal, and eventually the fuse just pops. Now, thankfully nothing burned up, nothing smoked, but I'm going to try disconnecting the rubber link. The motor itself is actually on a pair of mounts and then connects to the rest of the drive through a flexible coupling, and the coupling ends have Allen keys on them. So I can at least unhook the motor, make sure that's rotating, make sure the field windings and everything are fully intact and it'll actually spin under power, and then I can go to dealing with all the mechanics, getting the worm drive cleaned up and running, and go from there. So that's where we are. And hopefully in a week or 2, when the snow has all melted and I can go outside again, we'll be right back at work on the jukebox.